Assalamu alaikum warahmatullahi wabarakatuh. My name is Maran Muhammad Magdi. My metric number is 20865. And today we're gonna talk about the Arduino reader system. So, without further ado, let's start. The project objective and the primary goal for this project is to build a simple yet effective functional radar system that it can detect these objects, measure the distances, and display this data visually. As you can see, the objectives are the hands-on demonstration, the object detection, and the visual display. So let's talk more about the components and the sensors that are used in this project. The first and the most important one is the microcontroller, the Arduino Uno R3, which basically is the brain of this project. It processes the inputs from the sensors and sends control signals to motors. It's very compatible with a lot of the sensors, so it fits perfectly for this project. Next is the ultrasonic sensor, the HCSR04, which is actually really cheap. This sensor measures the distances by emitting these ultrasonic waves and calculating the time that it takes for the echo to come back. So basically, it's like a dolphin. It's also very reliable in detecting these objects from a 2 centimeter to a 40 centimeter range. Next, you have the 180-degree servo motor, which you mount the sensor on top of it. It's a very small, not powerful sensor, but it's very perfect for this project. So it can rotate the sensor to scan the ultrasonic sensor to scan the surroundings and allow for like a almost semicircular field of detection. And of course, we cannot forget the cables, the male to female, and all of this. It's important for the connections between these components and sensors. Next is the block diagram of the radar system, which outlines the flow of the data and how each of these components interact with the system. So first we have the input stage. The process begins with an input, the desired condition or target. And next is the sensor measurement. So the ultrasonic sensor, it gathers this real world data and sends it to the Arduino. And for the processing stage, you have the Arduino to calculate the error, like the difference between the input and the actual sensor value. And then it generates the control signal. For the output stage, it presents the feedback to the user, and the servo motor adjusts or corrects the system as needed. And you have the feedback loop, of course, for the ultrasonic sensor that it continues to monitors and changes and updates back to the Arduino for like real-time adjustments. And next, we have the circuit diagram. You can see for the radio systems, pretty straightforward. You have the VCC and the GND pins of the ultrasonic sensor and connects to the 5 volt of the ground pins on the Arduino. And you have the trig and the eco pins linked to the digital input and output, respectively. And the servo motor connects with the pin on the Arduino. So let's talk more about the methodology or the control strategy, where one of the main sensors is the ultrasonic sensor, and it operates by emitting, like I said, the ultrasonic waves at the frequency of 40 kilohertz. So this waves bounce off the objects and return back to the sender, which calculates the distance based on the time that it takes for the echo to return. And of course, the Arduino plays a central role in this, where it activates the ultrasonic sensor to emit the pulses and sends signal to the servo motor to rotate incrementally, because we had a problem with this as well. And yeah, this entire process is repeated continuously to provide real-time data and visualize it later on. So for the software installation, the Arduino IDE, it's basically essential to put the code for programming the microcontroller and includes several important libraries, the servo library, which was not installed, so gave us kind of an issue. So have the trig and echo pins that are defined to handle the ultrasonic sensors, the input and output. And for the variables, you have the duration, you have the distance are created to store the time and calculate the distance. So the formula that is used in the distance, it equals the time multiplied by the speed of sound, which is 0.034 centimeter per microsecond. And then it's divided by 2 because it accounts for the round trip that the echo bounces off the object and comes back. Now more on to the idea, the processing for software, where it's a software that translates this raw data from the Arduino into a reader display. So it uses a serial communication where it establishes a connection with Arduino to receive angle and distance data in real time. And it uses this trigonometric calculation to process the plots and objects on a graphical reader interference that we're going to see later on. And it has real-time updates and refreshes continuously as well. So let's talk more about the setup of the code. And one of the crucial aspects is, yeah, this communication between the Arduino and the IDE. So the processing software, excuse me, the serial event function, it reads this data as a string, then separates it into the distance values, then converts it into integers for use into the reader display. And the IDE uses this data from the Arduino to create like this display, and the draw function, you can see that it continuously updates the radar. It can render elements like the radar arcs and the rotating lines and these detected objects. Then it also doesn't hurt to have like these helpful functions to draw the radar and the objects to handle this, like the graphical elements to so you can see the visual data in the interface. And now we can talk about the applications of this system. It can be used for robotics and like self-driving vehicles, security systems, and recently the mapping and surveying, where people use it on their farms for their drones. They just buy like a small drone and put it on top of it. It's becoming more and more popular nowadays. So let's walk through the demonstration. And yeah, you can see here, let me pause it for a second, where you have the servo mounted, the sensor mounted on top of the 180-degree servo. And the ultrasonic sensor, it keeps emitting these pulses to gather the data about the distances. And this information is sent through the IDE, which updates the reader display, showing these red dots for detected objects, and the arcs, and this arc represent the scanning field. All right, so this pretty wraps up the presentation. So yeah, just to finalize everything. So this project, it demonstrates like how affordable it can get, because this sensors is really, really cheap, especially if you buy it from online websites like Shopee. And you can combine these components to like create a functional radar system by using these components like Arduino, the ultrasonic sensors. So you can build a tool that can be also used for educational purposes, but also as a hobby if you're interested in that. So that wraps it up. Thank you so much for listening, and have a good day.